Hello my friends, welcome to experiment 4. Today's experiment will be about basic operation amplifier configurations. In this experiment we will see 8 of them. So before beginning the experiment, let us check our devices. This device can be found from here. It is signal generator. This op-amp could be found from here by typing op-amp, and you know the scope here, you can take it, and for these sinusoidal generators, you can use this menu. And let us check the configurations. For voltage converter, Vout will has the same sign with the input, which absolute value of it is bigger compared to the remaining input. In the theory, the gain will be infinite. However, in practically, they will be equal to the supply voltages. For non-inverting amplifier, Vout will be Vin times 1 plus the ratio of these two resistors. And for inverting amplifier, Vout will be minus V input times the ratio of these resistors. In non-inverting amplifier, we have this term. In non-inverting amplifier, we have not. So that's why the inverting amplifier is more popular. And for voltage follower circuit, it seems like it is useless. However, it is very useful for buffering operation. It just isolates Vin and Vout. And for inverting summing amplifier, each input will be summed according to the ratio of these resistors individually. So for differential amplifier, Vout is equal to the subtraction of these inputs. And for make things easier, we choose R1 is equal to R3 and R2 is equal to R4. And the calculation of this formula will be easier. For differentiator amplifier, it takes the derivative of input function and it is multiplied by these terms. So for integrator, it takes the integral of the input function and it is multiplied by these terms. Since these two configurations require lots of mathematical proofs. For example, we should choose a simple time domain function in order to show the results. We will just see if this differentiator takes the derivative of the input or not, and this integrator takes the integral of the input or not. For this step, it is enough for these configurations. So let us begin with voltage comparator. Here's our voltage comparator. Let us simulate our circuits. In debug, let us open the comp scope. So this yellow channel corresponds to that inverting input. Blue channel corresponds to the non-inverting input, and the red channel corresponds to the output. So let's see. As you can see, if the inverting is bigger than the non-inverting, then the result will be minus. If the non-inverting, which is blue, is bigger than the inverting, which is yellow, approximately 2 volts and approximately minus 1.5 volts. So the result will be non-inverting. So a positive voltage. Okay. The comparator seems it is working. For non-inverting amplifier, we expect that the gain will be 1 plus 3.6 kilo ohms over 1.8 kilo ohms. So gain will be 3. So let's see non-inverting scope. Here is our input as yellow color. Here's our output as blue color. Yes, as you can see, the gain is 3. So for inverting amplifier, here we expect gain as minus 2. We expect gain as minus 2. Now let's see. Back. In scope. And yellow is input, blue is output. Yes. Minus 2 times input signal. Okay. Then what about the voltage follower? As you can see, they are the same. No difference. The gain is equal to 1, as we expected. Now, what about the inverting summing amplifier? Let's see the sum scope. It just inverts the summation of the inputs and multiplies it with gain 2. So here is the input 1 volts, input 2 in here maybe, that's 1 volt in here, and approximately 200 millivolts in here, and the summation of them are 1.2, and here is the result, minus 2.4 maybe. Now for the differential amplifier, let us see the subscope. Okay, here's the input, 1 volt from input 1, and approximately 200 millivolts from input 2, and the subtraction of these two is equal to approximately 0.8, and since the gain is 2 for each input, and approximately we see the 1.6 volts at the output. So what about the differentiator? Here is the input as yellow color and the output as blue color. From calculus or mathematics, or from signals and systems maybe, we know that the derivative of the triangular function is equal to the square function. If you take the derivative of this slope, since it is increasing, we will get a constant number as positive. However, since it is inverting the input, we will get the minus output. So for this slope, again, the derivative of this slope will be minus. However, since it is inverting the input, we are getting the positive constant signal. So what about the integrator? Now we are applying square wave to the input, and from your lectures you know that if you integrate the square wave, you will get a triangular wave at the output. And since it is inverting, we are getting the decreasing slope at the output. So by the way, if you want to adjust the generators, here are the buttons and knobs. Okay, that's all for today. Thanks for watching. See you in next lab.